Hi everyone and welcome back to the E5 podcast. My name is David, SparkyNinja, and today I am joined with very common partners on the E5 podcast. Who have we got tonight?
Hi, I'm Paul, aka Paul.
Paul.
Yeah. Hello, and I'm JW.
JW, good. Well, welcome back, and we've got with us another special host who's here for, is this number 4? I think, because, well, you know, it's a subject that we are really exploring and enjoying. So who is it? Who's coming back?
Hi, I am Sean Passon from Dehn, UK. I'm the technical manager. I'm also vice president of Atlas, and we're going to talk some more about lightning protection and surge protection, I think.
I think so. I think it's actually been, we've had a few podcasts where we've kind of just tapped into unlocking more information, and this has definitely been one of those subjects where we've just unlocked more and then we've wanted to discuss more. We've covered on a couple of the previous podcasts risk assessment lightly, and I think we've reserved it for this one because I initially looked into 6305-2 and I looked into a bit of the risk assessment because we discussed it right at the beginning of this series here on lightning protection. But it's a lot larger than it first thought, because it's the whole of the actual standard of -2. So well, I obviously commented on the comparison between that and 7671's calculated risk level. So, Sean, did you just want to maybe run us briefly through how this risk assessment works?
Yeah, okay. So I've got my copy of the Dehn Red Book. So if you are listening or watching this, if you've downloaded that, you should be able to follow that as well.
Yeah,
okay?
there'll be a link to download that in this podcast if you're looking on YouTube. So pause now, download, and then carry on. If you're driving, come back later, download, read, because it's good information. And I think Sean's going to stick with this so that we have it to refer to. So
yeah, it is. So all in our Red Book, it all kind of starts on page 34 is where the risk assessment part starts, and we go through it in exactly the same way that the -2 document does. So the risk management, as they like to refer to it in 6305, is the very basic way of establishing, but it's kind of fundamental to everything else that follows, whether you need lightning protection, and if you do, what level do you need to mitigate the risks? It is building specific. You cannot just look at a structure and know you need to do this risk assessment. So the first thing you're going to do is you're going to work out the area of collection. And there are 2 different areas of collection to look at. There is the area of collection for a direct strike. So that is the volume of your building. Because the standard considers anything within 40 meters to be a direct strike, you're also going to look at an area around that. And it's a little bit like unpacking a box. When you move and you get those foldable boxes and they all come unpacked and you have to build it, that's what you're going to do. You're going to fold the sides down, you're going to kind of round off those corners and look at that whole kind of area, because we know lightning doesn't just strike the tallest point. You're then also going to look at your wider area of collection. So not your direct strike, your area of collection for strikes near to the structure. And that actually is going to be affecting any of the lines coming in for a distance of 2 kilometers either side of that service entry line. So if you've got 2 kilometers either side, and the standard goes up to a maximum distance that it will assess up to 1 kilometer away. But if you were to use that 1 kilometer length by totally 4 kilometers wide, you'd have 4 million square meters that you'd be assessing, and you would need a lot of SPDs, because that's going to drive your requirement up, and it's also going to drive the number of potential events you would see up quite high. So what we want to do is make sure that our line lengths are correct. And when we talk about line length, a lot of people, when you ask them, their default answer is, well, I don't know, how would I? We don't want to know where the power station is. We don't want to know where the local DNO substation is. We want to know where the nearest next safe node point is. And for your structure, what we're talking about is, where is your transformer? That's what we want to know. And your transformer is very rarely a kilometer away. In fact, it's very rarely even 100 meters away. So you can see that if you can reduce that kilometer line length, which is the default value that the standard sets, if you don't know, by the way, it sets a default value of you must assess 1 kilometer. If you do that, you're assessing a huge area. If you can reduce that down even to just 50 meters, and it's probably unlikely your transformer will be that far away sometimes, you're taking away 950 meters multiplied by 4 kilometers. So your risk immediately is absolutely tumbling. You're taking a huge chunk of that away.
So excuse me for jumping in. If we do that and our node, which is the transformer, is within our, let's say it's, I don't know, 20 meters in a compound within my site, do I need to go beyond that?
No. So you're taking it from that point where the transformer is, because you can get some protection across the windings of that transformer. That's considered to be your safe node point, and you would assess your incoming line length from that point. Okay, so you're going to assess that line length, that 20 meters coming in, and you're going to do the same for all of your other incoming services. So if you've got some data cables, some telephone cables, anything that's conductive, if it's fiber, you don't need to consider it. But if it's a conductive service, whether it's Profibus cables, telephone cables, coaxial cables, you're going to consider all of those coming into the structure. And the way that you should think about it is like a wagon wheel, with the hub in the center being your building, and the spokes coming out being those service entry lines being connected onto things. And we're also going to have a look at how big those connected structures are. So you're not just looking at the direct strike, you're looking at the indirect strike risk, and you're building up these two different areas of collection. You're then going to start looking at where that building is in terms of how isolated it is. If you look on page 35, you'll see there are 4 different factors that we look at there, and we look at the relative location of the structure. That's the CD factor that I talked about in the previous podcast in terms of how isolated a building is. We also look at the routing in terms of looking at the routing of those conductors. It's looking at the transformer, whether you've got an LV transformer or an HV transformer, and it's also going to look at the environment, whereabouts it is, and whether there are bigger buildings around it, and if there's lots of urban sprawl, you've got lots of current division. So if there was to be any kind of indirect lightning strike, that gets divided up, so all those buildings around are going to get some of that energy, and your structure gets less of it, so it mitigates that risk away. And it starts to build up a risk picture that's unique to the structure that you're looking at. So it's quite complex, hence the reason we need to have software to do it, because there are so many inputs. I think I mentioned quite early on, it's a 14-page questionnaire we send people.
So this kind of, if you don't mind, I'll bring this back to wiring regulations for the electricians learning. There was, I believe, in our earlier podcast with Kirsty, when we went through the requirements in the 18th edition of the wiring regulations, regulation 443.4, which said protection against transient overvoltages shall be provided where there was serious injury or loss of human life, interruption of public supply, damage to cultural heritage, or interruption of commercial activity or industrial activity, or affected a large number of co-located individuals. Now, that kind of was a blanket thing.
Yeah.
And one of the things that we discussed was, it was almost like, take the 4 options, please take the 4 options, because if you go down the risk assessment level, as you mentioned, the 4 kilometers, each one of the stages of the breakdown of the risk assessment within 7671 allows for a maximum of 1 kilometer length for the LPAL, LPCAL, LPAH, and LPCH values. So it's fairly evident the wiring regulations were tinkering with something that's evidently quite a bespoke level of expertise. And already, my personal view, this should not be in the wiring regulations. It should literally be limited to that regulation, and in my view, now more than ever, there should be a statement that says where a risk assessment needs to be required or is required, a further consultation shall be sought from industry experts. Because I think this is muddied the waters massively for surge protection in general.
I'd agree.
And I think from the last 3 or 4 podcasts, because this is kind of like in this series, this is number 7, talking about surge protection and lightning protection. The last thing you want to do for electricians is muddy the water, because at the moment they're just being told by area engineers and inspectors, just get the client to sign a bit of paper that says they don't want it, and that's it, which is immediately setting a bad behavior industry wide.
Absolutely. I think, you guys will know better than me, and certainly John, with his background of domestic work, will know that for the average jobbing Sparks, he's neither got the time nor the information readily to hand to be able to do this. So he's already on the back foot. You know what I mean? He's got a client kind of asking for his quote. He's still got to sort all his paperwork out from the last job he did. He's got the accountant nagging him, and he's supposed to phone up the DNO and get them to give him a complete breakdown of how much is above ground, how much is below ground, how much is high voltage, how much is low voltage. That's not going to happen.
This is why they rely so heavily on the information from their competent person schemes. And this is why I've got the time to do this.
I've said a lot of the Alexis that it would be good for electricians to be able to develop a framework in their head of understanding on when you need to apply type 1, type 2, type 3, and do it like you would select a Type B or Type C or Type D brake or an RCD. We should be on, as an industry, we need to be in the next few years almost on a cruise control. We need to be comfortable with surge protection is here. There is a benefit to it. There is a cost and risk benefit. There's lots of specialists who tell us we should do this. There is a clear and concise and unambiguous regulation. And if I'm out in the middle of nowhere and an industrial factory, I should be looking for a Type 1. If there isn't, I should be looking at Type 1 here. I should be looking at Type 3 on any BT. You know, they should be able to do that selection and erection just on cruise control. Yes. We're not there as an industry because I think we said it in a previous one. Maybe these committees are just not, maybe they're taking stuff like flash density maps, putting it in, but without contextualizing it or making it too hard for the installer reader of the regulations to understand, or giving them a chance to succeed in understanding it.
Yeah, I would say that this looks like a classic case of people not really understanding who their target market is, because for the guys that do the big industrial stuff, well, that's covered immediately by the shall install. So this really does come down to only really the domestic market, where none of those four categories are there, and you know, we do get some domestic, I guess, that's fed by an overhead line, because there's a requirement for overhead lines as well to automatically have a Type 1. But for those large numbers of kind of urban, you know, semi-detached houses and terraced houses and things like that quite a lot of Sparks are working on a day-to-day basis, they're just not going to have that level of information, and that section of the standard and that CRL, calculated risk level calculation, it's pretty much useless and redundant, because they're not going to do it. It's just as simple as that. And the standard then goes on to say that if you choose not to do it, you just shall install an SPD anyway. So why give yourself that back door of you don't have to do it, and then also make it so complicated to do anyway? So I'm not a fan of it, I have to say. I'm not a fan, and I think you're right. It makes SPD seem like they're difficult and complicated, which automatically switches people off. And I know we've talked a lot in all of these podcasts. We've talked about winning hearts and minds, and it's hardly going anywhere to win hearts and minds, is it? It's not making people embrace an SPD. It's making people think, oh, really? Do I have to do this? It's another thing.
And this, I think, if I dare say it, some of this sits at those who have been the guiding light of our industry for a number of years, because we've only been doing this for a few years. And I genuinely do believe that the industry bodies need to put more out there and get themselves more out there. Now, I think it's fair to say, though, a lot more in the last 3 to 5 years, the industry has massively, there's far more visibility from industry bodies. But what I think is one of the things that is quite annoying is we've been to industry events where, industry bodies have been asked a difficult question by a intelligent installer, and they've kind of palmed them off with, no, you don't need to worry about that, or we'll cover that again, and not giving them the answer. Which, if you're going to, I've always said this, if you're going to stand up in your peers and talk about a subject matter, know the matter, or just sit down and shut up.
Yes.
I would never stand up and do a talk on lightning protection until I had done umpteen amount of practical engagement, you know, doing the work, doing the theory, applying the theory, practicing the theory, understanding the theory, looking at the practical application before I dare. And even then, it would only be my interpretation of those standards. And this is where I think the Red Book is quite good, because a lot of people will have listened to these and gone, I can't get 62305, because, as John said, it's like 1,300 odd of the Queen's shillings, which is quite a lot. But yeah, the risk assessment, this CRL, calculated risk level, I mean, does anyone know where this 1,000 came from? Is that just a number someone plucked? Because I've never seen where it doesn't explain it in the regs.
What the solution between if you do or
you know,
do not.
if the CRL is greater than 1,000, protection against atmospheric transients is not required, and if it's below 1,000, protection against it is required. Where did they come up with that? Did someone say, oh, it might be 500? Oh, well, we might not need. Well, just bump it up. Who comes up with these numbers? Where's it come from?
I genuinely don't know that. It's something that we've discussed internally as an organisation. I believe it has some, albeit maybe a previous standard or an international document. I believe there is some.
Yeah, it'll be buried somewhere in some.
I can't specifically remember which manufacturer it was, but I was doing some CPD on SPDs, and they interpreted the 1,000 to mean that obviously if you were lower than 1,000, then there was less than 1 in 1,000 chance of a lightning strike.
Mm-hmm.
And they said if you were over, it was you're over 1 in 1,000, and they worded it that way to their interpretation of why we use 1,000. I have no idea if that is actually genuine, but that's what the specific manufacturer interpreted to how we pass that information to a client.
Yeah.
You know, so if we say we've calculated 850, we could then say, well, if this was X, then it would be 1 in those, but it's actually 1 in 850, which is more likely. I don't know if that's actually true to why the 1,000 is there. But that's what I found on that.
That doesn't sit with the tolerable risk levels that are in 6305 because they are 10 to the 4 and 10 to the 5. So you're talking 10,000 and 100,000. So it's not in line with those. But I can imagine that conversation happening, if that makes sense. I can imagine someone thinking that gave it some scientific credibility.
I don't remember where I'm going to try and see if I can find out where I saw that.
It seems.
Yeah, I'm going to. Well,
yeah.
Sorry, John.
Yeah, I was saying it's a bit arbitrary. Someone's just sort of picked that 1,000 because whatever you do the calculation, it comes out as 999. So yeah, I mean it's not as if lightning only strikes if it's below a certain number, and once it goes above it, it suddenly doesn't. So,
but this is so. What bothers me is if you look at the effects of electricity on a human being, there are lots and lots of standards going back, way back to when these scientists were doing their tests, etc. There's information as to where you can go back and find out why we chose 30 milliamps, etc. as thresholds for various things. And I mean, I've even got the video, thanks to, I've still got to publish it actually. The original manufacturer of RCDs, I brought it back with me from Austria, a video of the original scientist actually wearing copper shoes and holding on to copper probes, putting current through him to create that table that is in the standard to this date. So at some point I'll put that on a RCD video for people to be shocked at once I get the German translated. But I'm always a fan of being able to find the logic and the reasoning as to why there should be a white paper or a technical a PD, an IEC PD somewhere that defines and justifies that. And this is the trouble, you see, because we talk about hearts and minds, right? You go to Alex, and somebody who's just a standard spot, excuse me, mate, where'd you get the 1,000 from? If no one can answer it, the whole room walks away.
Yep, absolutely. Yeah.
The whole room walks away because the industry is seen as colluding or being deceptive.
Mm-hmm. Yeah.
And that's bad form on something that we know has a genuine safety enhancement to a fixed installation. Do you know what? Let's be honest about it. I've always said to people, a surge protection device is one of the real sole devices that genuinely does protect the fixed installation. Rather than the human being side of it, it's a fixed installation protector.
Yes.
But if you can't answer those, the industry can't answer those questions, it loses the hearts and minds. It doesn't help the industry bodies then just saying, oh, if it costs too much, just get someone to sign off on a little bit of paper and issue them a form. What we're doing is we're kicking the can down the road.
I found out where I found that from.
I knew you would. I was stalling, by the way, Dave. Hope you realise.
It's the Beamer guide.
Is it really?
Okay. Yeah, I'll read it. The calculated risk level on the Beamer guide on page 65. It says 443.5 adopts a simplified version of the risk assessment derived from the complete and complex risk assessment of 62305-2, which Sean is talking us through. It's best seen as a probability of chance of an installation being affected by transient overvoltages and is therefore used to determine if SPD protection is required. If the CRL value is less than 1,000, it's got in brackets, or less than 1 in 1,000th chance. Right. SPD protection shall be installed. Similarly, if the CR value is 1,000 or higher, brackets, or greater than 1 in 1,000th chance, then SPD protection is not required for the installation. That's where I saw it.
Okay.
That's the Beamer guide.
Well, you've totally taken the wind out of my argument and debate there, but thanks for that, Dave. So I'll shut up. Anyway, Sean, would you like to continue your the journey through 62305? Now that
sure.
that off. Thanks, Dave.
Once we've kind of got our area of collection, we're then going to start looking at probabilities. So then you start looking, and we're kind of continuing now onto kind of page 37. And so you start looking at protection measures that are applied to the structure. And first thing it looks at is there a lightning protection system? Well, most of the time when you're doing this, you're doing it on a new build, so there probably isn't one. But of course, there would be an occasion, particularly as I keep referring, is if you have a system, you should be revisiting the risk assessment. So this is where you put that information in now to see if that's going to mitigate those risks or not. And then you start looking at the different external lines you've got. And effectively, you're building up a picture constantly of the building, the uses of the structure, the number of people in, and you kind of go through each of these different stages, the type of surface that people will be standing on, both internally and externally, because that relates directly to the step potential risk. So you want to know if it's got carpet inside or has it got tarmac on the outside and things like that. These are some of the things that when we ask these questions, people are like, why do you need to know that? I thought lightning struck the roof.
Do you think we oversimplify this then?
I think a lot of people do, yeah. I think a lot of people, and I've been doing this for a really long time, and throughout my entire career, people have always kind of been like, lightning protection, that green bit on churches, and that's kind of, that's always people's kind of default setting. It's also weirdly, given that it is quite a small niche subject, I don't really like telling people, if I go to a party or a barbecue or something like that, I don't really like telling people what I do for a living, because two things will happen. Immediately, someone in the room is the world's greatest expert in lightning protection, and you're kind of like, well, that's funny, because in nearly 30 years I've never come across you. And then secondly, someone will always say, yeah, only hits the tallest point, doesn't it? And it never strikes twice, and it's kind of like, oh, come on, these are
just easier to go, and then carry on with your beer.
Yeah, absolutely. Yeah. So, but you're building up a picture all the way through of, overhead lines, floor types. There's areas to put in things like, has it got EX zones? So has the structure got something dangerous inside it that you need to consider? That will have an immediate impact. What kind of firefighting measures has it got? Because lightning starts fires, and if you've got really good firefighting measures, that's one way of mitigating out some of that risk without needing lightning protection. You should bear in mind though, if you have an EX zone, doesn't matter what firefighting measures you've got, it immediately discounts them, because once the building's blown up, the sprinkler system doesn't work as well. So it does discount some of them. And then you just kind of go through each of the tables, and there's a lot, as you can see, if you're looking at this document as we're doing this, you'll see there's an awful lot of different kind of bits of information that you need to put in. There's quite a lot of different things to put in. For every single one of them, if you don't know a value, there is a default value. But of course, as always, the default value errs on the side of caution. And if you put default values in all the way along, your net output will be that you need an awful lot of lightning protection and an awful lot of surge protection. So you want to try and drill into this and get it as accurate as possible. The more accurate you make it, the more site specific it becomes. And ultimately, the fewer SPDs you'll need and the lower level of lightning protection you'll need. And in fact, we act as a consultant, as a specialist consultant to the National Trust, and we've given them quite a lot of training on this to kind of really establish that a lot of times they were maybe turning an old kind of shed of a building into a cafe, and they would go out to tender, and someone would come back and say, yeah, it needs lightning protection, and you'd kind of look at it and you'd say, well, this National Trust body, it only opens 6 months of the year, and it's only open from 10 till 4. And that cafe, you can only fit like 7 people in it. What's the real risk here? And single story building, you do the risk assessment, and I was constantly going back to the trust and saying, you don't need lightning protection. You need a type 2 SPD to manage your business continuity, potential loss. You want to make sure you're dealing with any potential overvoltage, but you don't need that. And then the big stately home opposite it, which is a huge big pile of bricks, when you say to them, and that one over there, by the way, that doesn't have any lightning protection on, that probably does need quite a lot, and you should really sort your budget out. Let's not waste money on this tiny building, let's spend more on that building, get that one right. And that comes really from nailing this risk assessment and getting it as accurate as possible, because the more accurate you make this, the better the output is for you and for the client. This
is a bugbear with me with a lot of these processes, where a lot of people will just go, okay, there must be software for that, and they'll look for software. Software is a great tool only if you put the correct inputs into software.
Absolutely. And don't all IT professionals say garbage in, garbage out. That's what they say.
So you mentioned training there. So does the training that either Atlas or even Dehn provide cover this risk assessment, or do some
So it
with this?
forms quite a big bit of the accredited designer course. We do quite a lot on risk assessments, and we do a live example of a risk assessment where we go through why you might select that option and why you should maybe select that option. It's also something that, as an organisation, Dehn offer training on our particular software product. So if you want to buy our software from us, you can buy our software off of us. And yes, that does come with training. And that's something that we tend to revisit quite often in terms of either going back to a customer, and certainly now that we have more capability of doing things virtually, we can share our screen using something like Teams or some other app like that, and we can actually show the customer, well, actually, this is my screen, I'm going to click on a few things, and this is what you should be doing. So we certainly have that capability. And in the fullness of time, it's a standalone product at the moment, but in the fullness of time, it will become cloud-based. So you'll actually be able to save all that to a virtual space and go back and revisit those risk assessments in time. So it's a fairly powerful tool, and it does other things for you as well.
And that's good. That's good value. I think one of the things that bugs me is when we're selecting and erecting an electrical installation, we're not leading from a risk-based approach. Because Dave, goes on about this a lot, about we should always select and erect for the intended use, the users, who needs to access it, who needs to maintain it, etc. And it's like you were talking about we were just talking about the selection of lightning protection being risk-based, but I use the exact same debate on arc fault detection devices. Brand new, do we, don't we? So we know there's a minimum 2.5 amp current, or 1.5 depending on which manufacturer, but I always recommend that you use it on high current using equipment. Shower, and everybody I'll say that to, they go, oh yeah 9.5 kilowatt shower, but then I go, but hang on a minute, you're in the shower when you're using it. It's for series arcs under high load. Do you spend 19 hours a week in the shower if you're living by yourself? So is there an inherent value in protecting that circuit with something which is going to cost a lot of money to buy and also cost to run, because there's electronics in it, as JW's videos have dutifully shown? So again, it's risk aversion. Would I use it on a cooker? Yes, because a cooker is used a hell of a lot more within a home. Would I use it on an immersion heater? If it's my primary source of water heating, yes. If it's a backup that I switch on once every 20 years, total waste of money. And this is where we need to look at the pragmatic, what's the user doing?
Yeah.
And I think we're not very good. I don't think we're very good at it. Just a view.
Yeah, it's interesting here in the Red Book on page 39.
Yep.
Up top there, types of internal wiring.
Yes.
How to impact. So this is something most people wouldn't have thought of, in that your wiring in the building is part of this risk assessment.
Indeed, it is.
Unshielded cables, routing,
whether it's not, etc. Yep. It's also the resistance of the sheathing of the cables as well is something that's looked at. Whether you, as you say, whether you make large loops or not. I mean, typically people aren't just chucking cable in all over the place because it's expensive to buy, but trying to get this information can sometimes be very, very problematic. And if you don't get the information, you have to use the default value. And that's where the system kind of falls down a little bit, particularly when, as I say, some people offer these for free. So the amount that they want to invest in doing it themselves is not necessarily as much as it would be if you were doing it on a kind of consultative basis. You're actually going to sit down with the customer and talk them through it. And I know I have many conversations like that. We do an awful lot at the kind of, whether it sounds big-headed or not to do it, but the upper end of the market, we tend to work on things that might go bang. So if you're going to be talking to someone from a nuclear establishment, you can spend a bit of time and effort and go through this and get some real kind of detail and really drill down into it. And
you'll find that those are the kind of people that will give you the time to sit down and listen. Instead
absolutely.
of talking to them on a phone call or having a little walk meeting, they'll actually give you time.
Yeah, absolutely.
Make the time because they see the risk factor.
But you can imagine this applying this in a data center, for instance. This, for a lot of the engineers in a data center, is critical. It's critical to understand, because that data is so key that regardless of the cost of this, it's irrelevant based on the safety and continuity of that business and that unit. It's irrelevant. So there's going to be a lot of interest paid on stuff like this.
Also shows, though, I mean, we talked a lot about the fact that this would ideally be done at the beginning, at one of the standing points to do this kind of work. But obviously, if we need to then understand the shielding and unshielding and the routing of the cables, we've got to have that level of communication with the principal architect and the designer of the electrical system, as well. So there's got to.
6305 says that. It talks about that quite a lot in terms of saying that different people within the kind of construction team have roles and responsibilities. I just think that generally speaking, that's not been communicated very well by the lightning protection industry in terms of really stressing that, I need this information. And if I don't get it, what you will get will be a poorer product. You will pay more for it, and it'll be more protection than you really need. I don't think that's been stressed enough. And maybe because it's a relatively small industry, we don't have any big kind of, NG Baileys or Interserves and people like that in the industry that can throw a bit of money and a bit of weight into things. So maybe we've ended up allowing ourselves as an industry to just, okay, I'll just do a default risk assessment. Don't give me the information. I'll just do all the default values. I'll tell you what it comes out at. If you do that, the things you're only really then assessing are the dimensions, which someone will usually give you, and whereabouts it is in the country so that you can select the appropriate flash density. Everything else is set to default values. And what you get is a very, very boring generic risk assessment that will probably come with very little explanation of what you've chosen, why you've chosen it. It's an important subject, and I think more people should spend more time, both in the industry and also from outside the industry, understanding it and understanding which type of risk assessment to do. I say you can do 4 different types, and it's very important to make sure you're doing the appropriate ones for the project that you're working on.
The problem being is going back to the domestic contracting or commercial contracting Spark, who's there running a job, who has to solve this problem. I mean, if you look in the regulation, I'm talking about 7671 now. So calculated risk level equals FENV. So FENV, which is the environmental factor. Okay. So then you've got divided by, in brackets, LP, which is the risk assessment length in kilometers. So you have to determine it. And then you've got times NG, which is a ground flash density. And then straight away for FEND, it gives you 2 values. If rural and suburban, it's 85, which is a low number. If it's urban, it gives you 850, which is a high number. Okay, and if you do these, there's some examples in the wine regulations. It's kind of anything that's in rural suburban areas, you're going to be below, because of the multipliers, 1,000. So basically what you should be saying is if you're in rural suburban area, you're kind of doing it if the criteria are applicable. If you're in an urban area, there's a chance that you won't have to do it.
I have to say we've done some samples when this was first kind of coming out. Myself,
That's
and
how I read it.
And Robin's been on your podcast before. We sat down and went through a few of these and did some examples, and we basically found that unless you lived in a kind of fairly built up area, so you're talking kind of terraced urban housing, fed underground, then you are effectively always going to need SPD. And that's just it.
Yeah, that's the key difference, really. And that's what I do on the 18th edition. As I say, right, if you're out in the sticks, you're probably going to need it. If you're in a town, you might not. If your feed is overground, overhead, then you're immediately going to be, you will need it, most likely. And it's, the examples they've done in the regulations, I haven't got it in front of me, but they're pretty lazy. They're just one of them's just all underground, one of them's just all overground, high voltage, and I
don't really consider it a true risk assessment because there's not enough variables and factors going into it to load and unload it to take account for different circumstances. So as we've kind of established, just talking among ourselves here, if you're out in the sticks, you're going to need it, and there's almost nothing you can do to kind of change that factor because that FEMV value is so low and the threshold is so high. So as you say, it's not really a true risk assessment. Why would you bother doing that? You would just say, unfortunately, you need it. I'm not a fan of it at all. That the CRL, I don't think it's been approached well. I think the version before with the kind of AQ values, or whatever it was before, and
AQ2, wasn't it?
Yeah, I don't think that was particularly good either. I just don't think the 7671 has really grasped this properly and come up with a suitable method that's easy enough to be used, but also meaningful enough to really genuinely be considered a proper risk assessment?
I think it starts, if you don't mind me being brutally honest. So I've got a question for you, but one of the things that I remember discussing with someone at the one of the Alexis was they were talking about this is surge protection against transient over voltages, and then there was a talk, I think, from the IET where they were saying, well, there's a difference between a strike and a stroke. Absolutely. But what they completely forgotten about, and which is why they lost the entire room, was electricians don't think like that. They don't talk like that. If these terms have been, realigned in line with international standards, that's great, but that needs to go into the hearts and minds of electricians. So yes, strike directly on the building, great. Lightning protection 62305. Stroke deals with the after effects, where the energy goes, how it dissipates.
Yeah,
we've never been spoken to in that manner as electricians. So that understanding to me is a good first step. What we've gone to is we've gone from that first step going, pardon what, with all the industry trade bodies going, just stick a new, every time you change a board, put a type 2 in, job and knock.
Yeah.
What's your view? Because I generally say to people, look, if you're changing a board, it can't do no harm based on sheer the value that it could protect. What's your view on putting a type 2 device into a new domestic consumer unit? What's your view on it?
I think that these days, given the value of the contents of most people's homes and our reliance on electrical systems, we've got washing machines, we've got tumble dryers, we've got dishwashers, we've got freezers, we've got Xboxes, we've probably got kind of home hubs and things like that. We're plugging in phones and tablet devices. I think you'd be foolish not to do it. And I think, to be quite honest, the affordability of a single phase type 2 device, if you can't explain that in fairly simple terms to the end client, to explain to them what it does and how it helps them, and risk against reward, you should probably think about a different job anyway, because they sell themselves, really, I think.
So that's the problem, and that is one of the big problems, because what these guys will do, rather than sell it, they'll say, oh, my area engineer, my industry body are recommending it. And they'll find a one-page document somewhere to show the client and go, there you go, the NIC or NAPIT or ECA recommend that this is industry best practice, without doing the work. So all we're doing is springboarding over all of the knowledge to a rule of thumb. And the trouble with these rules of thumb, like the RCD 1667 ohms, is none of that knowledge is attained by the individual. Yep. And we are now an industry living on rules of thumb, which become wives' tales, which become speculative crap, which nobody can actually understand where that came from. Mm-hmm. And that's a big problem. So I know I'm venting and ranting a bit here, but it's.
No, I agree completely that it needs to come from a knowledge base, but it also just needs to come from a confidence in understanding it, which I suppose is why we're doing this, to give electricians the ability to have that confidence in knowing basically what the SPD does, and getting away from already some of the wives' tales that I hear a lot, mostly from Americans. I have to say, the one and done, that basically an SPD is virtually a voltage fuse. It's designed to fail. That's just not the truth at all. SPDs are designed to give you a lifetime of happy ownership. The testing protocol requires that every device that is developed and tested against it has to be able to withstand 20 different events. So that's 20 straight away. That's the minimum that the standard wants it to be able to do.
So are you saying that there is no device on the market that can test these wondrous things?
Yeah, I mean, it's a real issue, testing, because I know people want to be able to test, and I know that people will automatically, and I see lots of comments already on social media platforms where people say, yeah, but how often do you ever actually look at it? I understand all those things. It's quite hard to test an SPD, because to really prove that it's doing its job, you need to create a transient event and ensure that it triggers at the voltage protection level that the manufacturer says it will. And that means you need to carry a surge generator around with you. And they're a little bit expensive, and they're a bit big, and they might not fit in your van.
So even though BS7671 does kind of suggest that we need to consider dropping our IR test voltage down because it could operate an SPD, giving a false reading, we can't reverse that to say that we could use an MFT to actually test an SPD.
I don't really think you could, no, because you wouldn't be using the same kind of high frequency short-term event that effectively is a transient. So I don't think you necessarily would. One of the things I have kind of trouble explaining sometimes to some electricians is that it's not the same 50 hertz energy that you're usually doing. It's an entirely different wave shape. And generally speaking, most of the electricians we talk to don't want to talk about the wave shapes, and maybe they shouldn't. But understanding that it is a different wave shape, it behaves differently, is pretty important, because that will then take you away from this idea, as I say, that it's just some kind of voltage fuse, basically, which is a term I've seen thrown about quite a lot in about the last 3 months, and it never fails to make me gnash my teeth a bit.
Yeah, because I mean, I've always kind of assumed that whilst an MFT may provide a voltage that might result in the actual device closing due to it being a over voltage of some form, it most definitely isn't representative of the actual voltage and phenomena that it's designed to. I mean, a 10350 device, for example, has got nothing to do with the characteristics or performance of an output of an MFT doing a DC insulation test.
Absolutely. And if you saw the device that we use to create 10350, it's as big as the room I'm sitting in now. In fact, it's bigger than my kitchen. So, you know, the huge capacity.
These are microseconds, aren't they?
In fact,
nanoseconds. Wow.
Yeah, so typically, certainly a Type 2 device will quench a surge in 25 nanoseconds or less, and a Type 1 device is usually quenched in about 100 nanoseconds or less. So it's unbelievably quick. And largely speaking, most of the other LV distribution gear, because they're working in microseconds or more sometimes, they'll have no idea that transient has taken place. If you've got a good SPD and it's been installed correctly, routed to earth correctly, your line lengths are correct and things like that, they'll have absolutely no idea. So they will be sitting there quite happily. And because they're passive devices that don't trip, they don't need to be reset in any way, shape or form, that also means that they are largely viewed with slight suspicion, that you don't actually have to go and do anything to make that device kind of continue working. And then, of course, people will say to you, well, you can't really test it. You know, there are SPDs coming out now as well that you can leave on when you do your DC insulation testing. So there are some new SPDs that are coming out. Yeah, I feel I should do a corporate bit here and talk about the Dehn Guard ACI range. That can be left in place.
But that's important, because for us to think about maintenance for our new installations, we've got to think about things like that.
Yeah, and I've seen it actually a couple of times before where people have disconnected the SPD to enable them to do that insulation testing, and then they've forgotten to reconnect the SPD afterwards. And because it's in parallel and it doesn't stop service, it can go for many years without people necessarily realizing that it was disconnected. So nothing would annoy you more, would it, than spending a few £1,000 on lots of lovely SPDs and then someone disconnects them and inadvertently forgets to reconnect them. But yeah, it does happen. I've also seen people forget to put the earth on, and then when questioned about it, they genuinely said that they thought the SPD just stored the energy, which would be a bit of a miracle if it did do that, but you can never tell.
Yeah, if you can harness it, we can then reuse it. That'd be great.
Yeah, wouldn't it? Yeah.
Yeah, the actual this sort of understanding thing about how SPDs generally work, and the fact that it is completely different from most everything else electricians have come across, I think is absolutely critical, because I've seen comments where it's clear that they don't have that understanding. I saw one where they said, "Oh, can't you just use an over voltage relay or something?" And it's like, well, no, because it's just massively too slow. It's not even going to see any kind of surge coming in. And also then there's the thing where if you've got one of the types that needs a over voltage or over current protection, like an MCB, won't the surge chip the MCB? And of course we know it won't, because again the actual transient coming in is so quick that any kind of mechanical device is never ever going to actually react to that, because it's just simply too slow. And it's sort of because it's a completely different thing that most people haven't come across before. I think there's that sort of barrier there that they can't sort of get past it. They're so used to something they can't actually get over the fact that it's literally nanoseconds in length of these things.
Yeah, I think that's a good point, actually, John. And we try to explain that to people as much as we can. And fundamentally, an SPD is just a really quick switching device. That's all it is. And what it does is it creates a temporary short circuit to Earth for a remarkably short time. And then to avoid things like follow current that may come afterwards, it's then also remarkably quick at switching back again. And hopefully, if you explain it to people like that, that it's kind of a almost like a pressure relief valve as an over voltage driven kind of rapid switching device, you can kind of get people to understand a little bit more the technology, and you get less of the comments where people say that, it's snake medicine, how can this possibly work, it doesn't do anything, they're designed to fail anyway, etc. And then people go out and buy a £5 device that they've bought off Alibaba, but they expect it to fail, and that's a massive false economy, because the devices shouldn't be failing.
Well, you said this in the previous podcast. The problem is a lot of people have been used to their devices over the last generation just failing more readily, more regularly, and they just go, "Oh, that's knackered. I'll buy another one," or they'll buy a different model, where really they're just much more reliant or sensitive to these over voltages, but they're not actually picking that up.
Yeah.
Okay. So, chaps, if you don't mind, I want to turn our attention to YouTube, because this is one thing I'm probably very poor at. We get comments. We've had quite a lot of comments on our podcast regarding surge protection, and there's one chap, a gentleman by the name of Mr. Mark Holmes.
Yes.
Who I shall read his comment on our last, not our last podcast, our podcast with Robin, which it starts off with, "Disappointed. I need more answers." I don't know his voice, so for me, surge protection has been a specialist area that was outside my remit, even though I've fitted a few where my customer requested it. I realise this has been in 7671 before the 18th edition, but have not taken much notice. I am now expected to be an expert on the subject, gain the queue, and I'm having to install a lot with a little knowledge. I love the honesty. Most domestic type 1 and 2 single and free phase. Training is a vital part of this industry, so the sooner I can attend a recognised course, the better. I think he's saying hurry up and build your training academy.
Yeah, I think he is.
Now he's put 7 bullet points, and there's some valid points here. He says, I have no control over the DNO fuse if that fuse is 60 amp BS1361, and I fit an SPD that needs overcurrent protective device, which is less than 64 amp, then I rely on a DNO fuse. If the DNO fuse upgrade the fuse to 80 amp without my knowledge, who is liable? Because we did have this debate, didn't we, across the
overcurrent protection
of within the regulations. I can't remember the damn reg number. I'm hoping one of you lads do.
You looking for that regulation again? You always look for that regulation.
Do you know what the worst thing is? I've got 2 regs books.
It's on a page to the right at the top. I'm sure, because I've stared at that blooming thing.
Yeah, the trouble is I don't highlight them because I've got 2 books and I keep swapping them around, and just shoot me, okay?
I'll get my book.
Yeah, so there was the debate as to some, and this is the trouble. Some Sparks will see, they'll go out and buy a board, and they'll see an MCB protecting a protection device, and that manufacturer is saying we need you to rely on that overcurrent protective device, not that of the DNO. There's been much debate to and fro across both the podcasts, which has been fascinating, having both Kirsty and Richard on, and debating the interpretation of that regulation. Now, I think it comes down to the fact that different manufacturers have different built products. Some require additional overcurrent protection, some don't.
Paul, top of page 167, buddy.
So I should probably say that I've spoken to Mark about SPDs. I've corresponded with him via the excellent SparkyNinja Facebook page. So I have had some conversations with Mark regarding overcurrent protection, and he described in some detail some of the installations that he's previously carried out, and I think he was a bit concerned at the fact that in some occasions he's maybe put a 32 amp breaker in or something like that. It's difficult because I guess a lot of electricians are looking for a one-size-fits-all answer here.
Yeah, they can't.
And you just simply can't do that because different manufacturers want different things. And I know when Robin came on your podcast, it was a bit of a kind of elephant in the room moment because he said, you know what, Dehn, our philosophy is if you don't need to, don't fit that overcurrent protection device. And in a domestic application where you've probably got an 80 amp head, 100 amp head max, then particularly our device for that application is called a Dehn guard, and a Dehn guard, without having a fuse in, just simply by way of manufacture, it has enough withstand capability to cope with 125 amps all day. So you don't need the overcurrent device.
Has Dehn published any kind of spiel that kind of gives the electricians assurance on that?
So we have a white paper where it goes into some details of that, and that is available on our website. So if you go to that website and go to the downloads, and then go to the white paper section, and there is a white paper in there about overcurrent protection. It's not the same for all manufacturers, and I have to be honest with that. And I know you've had Kirsty on the program, and I know Kirsty's talked at length about needing that other device, and for her company and her devices, who am I to say that she's wrong? That's absolutely fine, and I guess that makes it difficult for electricians. So my advice to electricians, to be straight, is if you're doing domestic, commercial, kind of consumer unit stuff, then why would you fit anything other than the manufacturer's own SPD that comes with it? I wouldn't bother swapping out. I just wouldn't bother. And that's coming from someone that works for a company that sells SPDs.
I'm going to say that's coming from a company that doesn't actually make fuse boards.
Yeah, exactly. We don't make those. So,
right, okay.
So why swap it? You're going to get all that manufacturer's guarantees with it, and in a domestic application, do you know what? The risks are quite low. Put it in. It's going to protect the customer's equipment, and you're also protected because you don't have to take on responsibility as designer.
Which kind of explains, because Hager used to use Dehn on their domestic stuff. And now they don't. They've gone out and bought their own company, and they do their own thing. Dehn, in all fairness, are very much more commercial, industrial, very more high-end protection type systems, to be honest with you, in my personal view. But if you don't mind, I want to go back to Mark Holmes, because this man went to the effort of typing this comment, and by God, I want to read it. He then says in number 3, for domestic installations, there is a ridiculous situation of a get-out clause of total value of the installation equipment. Therein does not justify such protection. Which we all know I don't think it's a get out. I can see where he's coming from, but it's just not. It's more of a get in.
It's more of a get in. It's more of a.
But he then says, if electricians have to now look at BT lines, SAT dishes, aerial cables, network cables to cameras, it will be a lot easier to justify not fitting anything due to cost. I think what he's trying to say is we're going to look like prats if we walk around the house and go, oh, that's going to cost, that's going to cost, that's going to cost, that's going to cost. Because the homeowner will go, hang on, you're only looking at the electrics, not all this stuff. This has been fine for years. And he'll end up having to put a load of notes and warnings on his electrical installation certificate. But he then says, if I fit a surge protection device in a low voltage supply in domestic flats, but don't fit any into the phone lines, TV, SAT, am I liable if a tenant's equipment is damaged by lightning? My advice would be, if you have noted it and discharge your duty of care in writing, no, but you must offer that and inform them. No, don't just run away and go, oh, by the way, there's a note on the bottom certificate, and the homeowner says, well, I didn't know anything about it. So you should.
A lot of local authorities and housing associations are very aware now of SPDs, and they're also aware of litigious tenants. So they are abundantly aware that they need to be doing something about that. And some of your kind of split load board manufacturers, people like Bemco and Ryfield and things like that, they are starting to grasp this nettle as well, and they're starting to build SPDs in so that everything that comes back out is already protected. I know that doesn't necessarily cater to the data side of it, but there are organizations like the Confederation of Aerial Installers. They're aware, and in their standard it talks about SPDs, so you can, if you have an antenna that comes in and is then being split up to go to different tenants, you can put a single SPD in before that splitter, and then everything after the splitter is then protected. So it doesn't necessarily need to cost a lot of money, but again, it brings us all the way back to something that we keep talking about, is having some prior thought and installing it at the right point in the project. If you end up fitting an SPD in every single individual dwelling in a flat, you've probably not done the best job you could, because you probably could have put 1 or 2 SPDs in earlier on in that distribution system, or earlier on in that incoming data cable to protect it, and then everyone after that is enjoying that protection.
So I'm going to carry on, because Mark wrote a small novel and I'd be doing him an injustice. It's valid. If here's one. Not all surge protection manufacturers supply Type 3 SPDs. I didn't know that. for the network SPDs, BT, how do I coordinate protection for these situations other than picking one manufacturer who does a lot? I think you've just answered your own question there. But then this is one that's on all the Facebook groups. Do Type 3 multi-gang extension leads need to be part of the same manufacturer as Type 1 and 2? And how many times have we seen on Facebook groups where Sparks go, oh, I don't know, do I install it? What do I do? And then you get some more and go, yeah, just get a load of Type 3 surge protection extension leads, job done, it's covered.
Yeah. Please don't use those. They are not good. If you speak to anyone, particularly maybe London Fire Brigade, in terms of their fire investigation team, they'll tell you just how often those devices are the cause or seat, the start point of a fire. You should not rely on a multi-gang socket that may have a GDT built in somewhere or a suppressor diode tucked away in it somewhere as your surge protection. I would say most often in a domestic application, you are very unlikely to need a Type 3 device. So for people who don't know what a Type 3 device is, it is usually a much smaller device. It's a series device, not parallel like your Type 1s and Type 2s. And you would typically put it very close to a piece of terminal equipment or very sensitive equipment to provide a kind of last line of defense, almost like a fine filter protection for that specific piece of equipment. So for Type 1 devices, we want those near as possible to the entry point, but for Type 3 devices, we want as near as possible to the thing that you are protecting. It's unlikely in a domestic application that you'd really need a Type 3, to be honest. I can't see it in a power distribution system. And when you get into data devices, data's a bit more complicated, and you also don't have such of a worry in terms of coordinating your data with your power, because they are effectively separate systems. So it's not such an issue coordinating them, although within your data system all of your SPDs do need to be coordinated, and if you mix and match, you take on responsibility as the designer or prove coordination.
And that's Mark's last comment, is why can't different manufacturers be used if the correct protection levels are chosen? But again, if you look at regulation 534.4.5.3, selectivity between overcurrent protective devices is necessary to prevent danger. I think it's the exact same with surge protection. You need to ensure there's a level of coordination between let through energies, etc., so that these devices are working sequentially. But
absolutely. So a perfect case in point is the fact that Dehn only use spark gaps for our Type 1 devices. So that is a different type of technology to a Varista-based device. So if you tried to mix and match, you wouldn't necessarily know that our device would work with somebody else's. And Varistas exist in most things, and if you don't have Varistas that are coordinated together, you do at least need some kind of decoupling length between them, and you don't necessarily always get that. We actually have a great video amongst the training seminars that we present showing exactly that. Two Varistas close together, no decoupling, they're not coordinated, and ultimately the terminal equipment Varista gets destroyed because its voltage protection level is about 800 volts. So at about 800 volts, it starts to deal with all that energy, whereas the other Varista further up is actually set to 1400 volts, and it's not going to trigger until 1400 volts. But the tiny terminal equipment can't deal with that level of energy, so ultimately that Varista gets destroyed. So coordination is really important, and you can't really expect manufacturers to test each other's devices. I've got no responsibility, and my bosses in Germany would think I was mad if I said, you couldn't do us a favor, could you, and use our really expensive lab to test what happens if you put a FIRS device further downstream from a Dehn device. They would laugh me out. So, and you know, that's applicable to anyone. I wouldn't expect anyone else to do it and test a Dehn device. So that's not going to happen.
I think just to clarify a little bit what you said earlier on about, obviously we were talking about test equipment and whether you can test these devices, and you know the misconceptions out there. I'd just like to throw in a banner of support here, really, that a lot of people can't, but we have John Ward. And I'm sure behind that that imaginary screen of rotten switchgear, there is some device that he's borrowed on extended loan from NASA and a connection to a bulk supply point somewhere where I'm sure he can probably melt or blow one up or do something to it. JW, have you got any test kit, John?
Nothing that will actually do it, because, like I say, it's quite difficult to actually, as you say, test these things, which. I'm sure we can arrange some kind of demonstration.
There we go. You see, I knew that was coming.
I've seen your video, John, with your hand wound generator. So I've seen your content when you're showing that, and it's getting to 900 volts, and it doesn't go up anymore. So I've seen it. You've done that.
Don't worry, John. We'll figure out a way of boosting that.
This thing with the one of the comments you made earlier about the domestic stuff, this I think is part of a bigger problem in that for quite a long time and probably forever, a lot of domestic electrical work has been considered like the sort of the cheap bargain basement end of the market, and people just apparently don't want to spend the money. But this isn't actually true. All right, there's plenty of people out there that don't want to spend money, but there are plenty of people who, if you actually explain things to them and say, look, this device could potentially stop your TV from being destroyed, they're actually quite happy to pay for all this stuff. You just have to actually tell them and explain to them and basically sell the things to them and say, yeah, if these things are available, and yeah, you should be having them installed. So rather, I mean, obviously there's going to be people that say, oh, I don't want to pay that, I don't want to pay this, or whatever. But yeah, if you actually take the time to explain these things to certainly domestic property owners, a lot of the time they're quite up for having this stuff installed.
Absolutely.
And so just make the effort. And even things like AFDDs, which, as we know, cost like £150, £200 each. Yeah, not everyone's going to want them, but don't assume that somebody isn't going to pay for them just because it happens to cost £150 each, because they might want to pay for that stuff. And they may be circumstances where it's worth having.
One of the struggles for many electricians, I've had a couple contact me and ask me how to help translate codable observations to their clients, things like earthing and bonding, how to speak to clients in a way that is informative, authoritative, but supportive, and bloody English.
Yeah.
And it's a real struggle. First, the electrician has to understand themselves to then put it in the right language.
Yes.
And I still don't think we're there. We're definitely not there with AFDDs. And I think clearly because we've always had SPDs, because now the application of SPDs has changed. Now it's become at the forefront, and many just aren't there yet. And I just, I think we should a bit more time playing with them, experimenting them. Like Sean just said about, when you have them in series, explain differences between Spark and the, various, just this different type of SPDs, this kind of stuff.
What scares me, Dave, is I have a number of contractors, and I know more about SPDs and arc fault detection devices and RCDs than they do. And they do it every single day as their bread and butter. And I'm now in the nosebleeds doing the management and the risk stuff and everything else. And what I see is a scary, I think we did it in a podcast earlier on in the series where we met a chap called Harry, who was very open and frank and said, look, as they'll install any electrical system, but within their costing and their pricing, they need to allow the time to learn and adopt and understand these new systems. Any contractor's always got an appetite to do it, but along comes the learning and the implementation. Our industry is pants at helping individual electricians and business owners properly level up their skills and their knowledge. I just think they've lost the art of talking. And I think it's because they're private for-profit companies who only care about their bottom line and not generally, they don't have the experience of what it's like working in an electrical contractor or setting up and running their own electric. They have people telling them, but those people will be looking up to them going, I pay you a fee, help me. They don't have that mindset. I've always said this for years. A lot of the industry bodies have totally lost the pulse of the electrical contracting industry, not just the domestic, but the industrial. They just put a book out or say, no, this is the rule of thumb, or you just stay in your little box for now and we'll tell you what to do and how to do it and when to do it. And you have a lot of electrical contractors out there doing the wrong thing. And the industry bodies won't be there to dig them out, to bail them out, because they have systems and processes in place where if someone does something wrong, they have to go back and fix it. Who the hell wants someone who screwed up going back and
similarly,
fix it?
these industry bodies have, I watched one recording of one just earlier today, and it came to the discussion points on SPDs where he did one previously on SPDs, and he had questions, and they were the same questions that I've seen him answer again and again and again and again. About those four. About those four things. About do I need to? What about the length? I've been told I can't go too long, or I have to put another one in. And so they're regurgitating and they're answering the same questions instead of going, okay, we've done that. Now let's actually expand this understanding and this, this information for you to go further with that. The opportunity is just not there still.
But I do think
that's the same questions.
That's part of the hearts and minds, because that 10-meter rule, for instance, if you follow that 10-meter rule, you're putting in a hell of a lot of surge protection, which nobody's going to do.
And it's 5 meters in Germany, by the way.
So do we have surge protection devices every 5 meters in German electrical installations?
Quite often, yeah.
Wow.
Yeah. And
Germany crawl through their electrics.
Domestically, they're mandatory. So there's no calculated risk level. There's no if you've got this, if you've got that. It's just you will put it in. End of story.
And there you go. There's a 19th edition preview for you straight away. It's all becoming mandatory, folk. Resistance is futile, as they say in Star Trek.
And it's all German as well, isn't it? So it all comes back to Germany, doesn't it?
Thanks, Germany.
Yeah. If you go and look, the thing is, you can see a lot of stuff for free if you do a little bit of research in the DIN standards. I mean, not the details, but the structure. I had a guy ask me about, do they do inspection and testing in Germany like we do here? I goes, well, 60364-6 is a thing, and I found the DIN, and I found mentions of C1, C2, C3. So yes, they do. They just don't obviously speak about it or moan about it as much as we do.
Well, let's hope there's a 62305 Part 5, and then we can really start to get our act together.
I found a 60364-9, which looks like it's been rejected a few years ago, which was good. So Part 9. But, things to look forward to if that comes back up.
The swimming pool of BSEN standards, eh? Right, guys, we're well over time. I think we've kind of done this to get death. I think what we'll do is we'll leave this here, we'll park it, and we will come back to it maybe in a few months' time, 6 months or something like that, and see if there's any more further debate we can have.
There's two things are going to happen, isn't there? There's either an announcement of an amendment with an adjustment, or there's the opening of an academy, which we're going to go and visit.
Yes.
And discuss, and
sit there scratching our head going.
Sit there scratching our heads, but yeah. And then we'll do something about that, to let the other electricians know about it if we think it's a good thing. But yeah, it's been great.
Right, Dave.
Oh yeah, it's me, isn't it? Okay. Yeah. Any other inputs, John?
No, I think we've covered most everything pretty much there. So I say certainly from domestic stuff, just don't be afraid of actually trying to sell these things to customers, because if you assume they're not going to pay, then you're not going to sell one, are you? But actually tell them, and you'll find quite a lot of people are prepared to pay for this stuff once they understand what it's for. So.
Yeah. Again, don't forget to get that better understanding. We've done a number of podcasts on this. John's done his videos on his YouTube channel. And don't forget about this big red book. Description's going to be below on YouTube. Download that. But don't say, oh, look at that this afternoon. That's going to be something you're going to revisit. And let us know in the comments if you want us to cover areas or discuss with areas or particulars, or we can get Sean back in to highlight some key areas if there's anything that you guys really, really do need a bit of an understanding on. Do remember it's originally from Germany, so you'll see the density map for the German aspect. But is everything else pretty much okay other than that bit?
Yeah, pretty much. There's a comment in there if you're really reading it closely and notice it, where it says that you can opt to not do the risk assessment and just install a minimum level 3 system. We do not have that in the BSEN version of the standard. That is unique to the Dehn standard. So please don't do that.
Right, so there's no option to opt out of the risk assessment.
No, there is not.
BS
not in the BS
standard.
No, there absolutely is not. But there is in Germany.
Anything else, Paul?
I can only summarise it as mind blown.
Mind blown.
Yeah, to say the least, mate. Where do you even start? There's so much to take. This is most certainly one of those things where you have to sleep, eat, repeat, sleep, eat. This is something that you've just got to take in small chunks and develop understandings and start attacking and just going, right, what's this system? What's that system? I don't think we've ever done a series of podcasts, and I genuinely thank you, Sean, because in these, I think we've done 4 with Sean. So you're on a par now with Richard Bowler as far as people doing them with us. The volume of information in these 4 is absolutely incredible. So thank you very much, really. And that's all I've got to say on it.
Thank you for having me.
Yeah, and take that on board, though, because if we're at that point, then we're going to do more work on it, and we're going to obviously provide you with our findings and let us know.
Sure.
Which, but yeah, Sean, anything else from yourself?
No, just if you have any questions, as I say, I'm sure you're going to put my contact details in the description. Please feel free to contact us. Genuinely, we welcome contact from electricians. We know and appreciate that this is new for a lot of you, and so we are genuinely there to help. And usually, myself or one of my colleagues, within 2 or 3 questions, can be giving you the right advice on the right kind of device that you'll need and where best to put that. So please don't be afraid to contact us. That is genuinely what we're there for.
Excellent. And I'll actually just be a bit selfish and just say thank you for joining the SparkyNinja group and helping out. So there's been some great engagement with some of the people in there. You've put a lot of effort into your responses for guys in there, and if anyone is in the group, you can find him or on social media, etc. Okay, we're going to close this. I'm not going to say Paul's goodbye line, so I'm just going to say take care and goodbye.
Thank you. Goodbye.
Bye.